Today we're going to look at the increasing, decreasing, right and left end behavior related to exponential and logarithmic graphs. So the first example I have is actually exponential decay. And because of the equation and k being -2, the asymptote is at y equals -2. The rest of the graph is going to start in quadrant 2, and it may look like this. It would start and it would come down, and it would never cross the asymptote. It gets closer and closer, but it never crosses. So now, let's look at whether this graph is increasing or decreasing. We read a graph from left to right. So as we move to the right, we would say that this graph is decreasing. So we'll go ahead and write that down. The graph is decreasing. Next, we want to look at the left end behavior. Now, the left end means the left arrow. So maybe I'll go ahead and circle that. All right, so that's going to be the left end behavior. So what's happening if we think of this as being negative infinity here, positive infinity over here, you got positive infinity up here, negative infinity down here. So what we want to say, as the graph moves towards negative infinity, okay, as the graph moves towards negative infinity, the arrow is going towards infinity. So we're going to state it like that. So the left end behavior would then be, as x approaches negative infinity. So instead of saying approaches, we can just write an arrow. Then we would say y approaches positive infinity. So that's how we can state that. Now, the right-hand behavior would be the arrow on the right. This is the right, did I say right hand? Right end behavior. Now, this time, as x approaches positive infinity, and we put the arrow, we could say that y approaches -2. It actually approaches -2. It never quite gets there, but that's what it approaches. So those are your left and right end behaviors. Let's look at another graph that's logarithmic. So this time maybe we have y equals negative log base 2 of x minus 3. And this time we know that the graph is logarithmic because it has the word log in it. We also know that the asymptote is at x equals 3. So we'll go ahead and make a dotted line, vertical dotted line for that. So that's going to be your asymptote right here. X equals actually positive 3. I'm not sure if I said -3, but it should be positive 3. And again, we'll go ahead and make our infinity symbols. So we got infinity, negative infinity, and infinity here, negative infinity there. Now the graph's going to look something like this. Because of the negative right here, we know it reflects over the y-axis. And I said that wrong. It actually reflects over the x-axis. So the graph is going to look something like this. It's got a reflection over the x-axis. I think I said y at first, but it's actually the x-axis. All right, so the graph, as we look at this, again, if we go from left to right, this would be a decreasing function. So we want to say decreasing here. And we'll look at the end behavior. So if we look at the left end behavior, that's right here. That's the left end behavior. We can say this time, as now x doesn't approach negative infinity. X approaches 3. X approaches 3. It never goes past that. And then y approaches infinity. Y goes up forever. So that'd be your left-hand behavior. Your right-hand behavior over here, this time we can say as x approaches infinity, the y value actually continuously goes down, goes lower and lower. Looks like it might level off, but it actually goes towards negative infinity. So that's your increasing, decreasing, left and right hand behaviors in a nutshell.